Welcome to Moving the Decimal. So we've already talked a little bit about scientific notation, and here we're going to talk about how to do some manipulations mathematically with scientific notation and exponential notation. So, powers of 10. Here are some of the powers of 10. Not all of them, but some of them. So, something like 10 to the 6th is 1 million. That's 6 tens all multiplied together. So 10 times 10 times 10 times 10 times 10 times 10. 10 to the 3 is 1,000. That's 10 times 10 times 10. 3 tens multiplied together. 10 to the 2 is 100. That's 10 times 10. 10 to the 1 is 110 multiplied together. So it's just 10. 10 to the 0 is 0 tens multiplied together, but that's equal to 1. 10 to the negative 1 is, now we're dividing by 10. We're dividing by 110. So if we have a negative sign, we're dividing by that many tens. So we have 1 divided by 110, so 1 over 10 is 1/10. Right? That's 1/10. That's 0.1. 10 to the minus 2 is dividing by 2 tens, or dividing by 100. So that gives us 0.01, or 1 over 100. 10 to the minus 3 is 1 over 3 tens. Remember, 3 tens was 1,000, so we have 1 over 1,000, or 1,000th, so 0.001, and so on. So we can go to higher powers of 10 or lower powers of 10. So when we're converting from powers of 10 to fixed numbers, or regular numbers, we can use these steps. To convert a positive power of 10 to a fixed number, write 1, then move the decimal to the right by the number of places equal to the number in the exponent. So 10 to the 2 equals a 1, and then move the decimal to the right 2 places. So from here, you move it right, and then right again. So we have 100. To convert a negative power of 10 to a fixed number, write a 1, and then move the decimal to the left by the number of places equal to the number in the exponent. So we have 10 to the minus 2, we write a 1, and then we need to move the decimal place 1, 2 spaces to the left. So we have 0.01. So now let's look at multiplying and dividing by 10, 100, and 1,000. So if we need to multiply or divide by a number that is a positive integer power of 10, like 10, 100, 1,000, and so on, we have a few steps. When multiplying, we want to move the decimal place to the right. Sorry, we want to move the decimal point to the right by the number of zeros in the 10, 100, or 1,000. So if we're multiplying by 10, we move it to the right 1 place. If we're multiplying by 100, we move the decimal point to the right 2 places because we have 2 zeros in 100. If we're multiplying by 1,000, we have 3 zeros, so we're moving the decimal point to the right 3 places. If we have a million, we have 6 zeros, so we're moving the decimal point to the right 6 places. When we're dividing, we're moving the decimal point to the left by the number of zeros in the 10, 100, 1,000, and so on. So if we divide by 10, we move the decimal point 1 place to the left. If we divide by 100, we move the decimal point 2 places to the left. Divided by 1,000, we move it 3 places to the left. Dividing by a million would be moving the decimal point 6 places to the left, and so on. So when we're writing a number that has a value between -1 and 1, in other words, a number that begins with a decimal point, or 0 followed by a decimal point, we always write a 0 in front of the decimal point. So you should write 0.42, not 0.42. You should write -0.074, not -0.04. So the 0 in front ensures that you see the decimal point and that you don't mistake 0.42 for 42. Because if you have a 0 there, it should point out, well, you're not going to have written down something like this. If you write a really small decimal point, you might not notice it, especially if you're writing in pencil instead of pen. I also encourage you to write larger decimal points to make sure that you see that they're there. So often we need to convert between fixed notation and exponential notation numbers, and the sign in front never changes. The sign in the exponential term may change, but the sign in front never changes. The sign in front identifies whether the value of the number is positive or negative. The sign in the exponent, or in the exponential term, identifies whether the number is a large number or a small number. So, a large number is a positive exponent, a small number is a negative exponent. So, if we want to convert from exponential notation, say negative 4 times 10 to the 3, to fixed notation, say negative 4,000, the sign in front never changes. We still have that negative sign there. That doesn't change. In exponential notation, if the coefficient, that's the 4 here, is multiplied by a positive power of 10, we have 10 to the 3, so 3 is a positive 3. Then we want to move the decimal point in the coefficient here to the right by the same number of places as the value of the exponent. So in this case, we have 4, that's our coefficient. We're multiplying by 10 to the 3, that's a positive 3. We need to move the decimal point in 4, 3 places to the right. Well, the decimal point in 4 is just to the right of the 4, so we need to move it 1, 2, 3 places to the right, so we have 4,000, plus we need to add in that negative sign, so negative 4,000. So let's look at a couple of other examples. These symbols here are not negative signs, they're just bullet points. So 2 times 10 to the 2 is 200. Negative 0.00333 times 10 to the 3. We need to move the decimal point 3 places to the right. So we 1, 2, 3. That means our answer is negative 3.33. In exponential notation, if the coefficient is multiplied by a negative power of 10, then we move the decimal point in the coefficient to the left by the same number of places as the value of the exponent. So, if we have 2 times 10 to the negative 2, then we move the decimal point, which is to the right of the 2, we need to move it to the left 2 places, and then fill in the zeros, so we have 0.02. In this case, we have negative 0.00333 times 10 to the minus 3. So now we need to move the decimal point from here to the left 3 places, 1, 2, 3, and fill in with zeros. So it was here. We need to move it 3 places to the left, so it goes there. In this number, we have negative 7,653.8 times 10 to the minus 3. Again, we need to move the decimal point 3 places to the left, so we're going to move it from after the 3, 1, 2, 3, until after the 7 and before the 6. So that becomes negative 7.6538. Now let's talk about changing from exponential notation to scientific notation. In chemistry, we prefer to write numbers in scientific notation, which is a special form of exponential notation. So in exponential notation, we can write a number in multiple ways. So if we have a number like 6,538, we can write that in any of these ways, and they're all valid in exponential notation. We could write it as 6538 times 10 to the 0. We could write it as 653.8 times 10 to the 1. We could write it as 65.38 times 10 to the 2. 6.538 times 10 to the 3. 0.6538 times 10 to the 4. We could even have a negative exponent, like 653800 times 10 to the minus 2. And these are all valid ways in exponential notation of writing this number, 6,538. But in scientific notation, there is only one valid way of writing the number. 6,538 must be written this way, 6.538 times 10 to the 3. So, if we want to convert a number from exponential notation to scientific notation, we need to move the decimal so that the coefficient, or the significand, is between 1 and 10. And then adjust the power of 10 to keep the same numeric value. So, the value of the coefficient may be exactly 1, but it must be less than 10. Which means that you basically only have one digit to the left of the decimal point. That digit must not be a 0. It can't be 10, you can't have 12 point something in scientific notation. it must be a digit between 1 and 9, and then some number of decimal places thereafter. So, what we mean here then is move the decimal point in the coefficient to after the first non-zero digit, so something between 1 and 9, including 1 and 9, and then adjust the power of 10 to keep the same numeric value. So, if you had to move the decimal point one place to the left, you need to increase the exponential by one value. So, the specific steps involved here are, number one, leave the sign in front of the coefficient as it is. We never change the sign in front of the coefficient. If we're moving the decimal y times makes the coefficient larger, then we may need to make the power of 10 smaller by a count of y. So, if we have an example of 0.045 times 10 to the 5, we need to get we need to move the decimal after the 4, because that's the first non-zero digit. So we have to move the decimal 2 places, the decimal point 2 places from here, 2 places to the right, which makes the coefficient 100 times larger, which means we need to make the exponential term 100 times smaller. So 100 times smaller than 10 to the 5 is reducing that exponent value by 2. And so reducing the 5 by 2 makes it a 3. So 4.5 times 10 to the 3 is the same thing as 0.045 times 10 to the 5. This is a valid way of writing this number in exponential notation. This is also a valid way of writing it in exponential notation. But only this one is valid for scientific notation. And in chemistry, we always want to write our numbers in scientific notation, not exponential notation. If, on the other hand, moving the decimal y times makes the coefficient smaller, then we need to make the power of 10 larger by a count of y. So, if we have 450 times 10 to the 5, we need to move the decimal point after the 4. So it starts out after the 0. We need to move it to the left by 2 places. This is making the coefficient 100 times smaller. So we need to make the exponential term, that 10 to the 5, 100 times bigger. We need to change this 3, should not be a 3, that should be a 7. So we need to change from 10 to the 5 to 10 to the 7. So when we're moving when we're moving the decimal in exponential notation, if the coefficient gets larger, then the exponential term gets smaller. If the coefficient gets smaller, then the exponential term must get larger. If all you're doing here is just moving the decimal around and you're not trying to change the value of the number, if you make the coefficient bigger, the exponential has to get smaller. If you make the exponential bigger, the coefficient has to get smaller, and vice versa. If we want to then convert from fixed notation, or regular notation, numbers, to scientific notation, we need to know some math. So, any number to the 0 power equals 1. 2 to the 0, that equals 1. 42 to the 0, that equals 1. 236.89 to the 0, that equals 1. 10 to the 0 equals 1. And this is the one that we care about. In scientific notation, we care about this one. But remember, anything to the 0 power is equal to 1. And that is why 10 to the 0 is equal to 1. Because essentially we have 1 times 0 tens. Anything times no tens is going to be what we started with. That's still 1. So any number can be multiplied by 1 without changing its value. And this means that any number can be multiplied by 10 to the 0 without changing its value. So we can have 42, or we can have 42 times 1, and that's still 42. Or we can have 42 times 10 to the 0, and that's still 42. So, if we want to convert a fixed notation number to scientific notation, then what we do is take the number, write it down, and then add times 10 to the 0 after the number. Because remember, this doesn't change the value at all, since we're just multiplying by 1. And now, we apply our rules to convert from exponential notation to scientific notation. So we leave the sign in front alone, we write the decimal in the coefficient after the first non-zero digit. We adjust the power of 10 in order to compensate for moving the decimal. If we move the decimal point to the left in our coefficient, then the value of the coefficient is getting smaller, which means we need to make the value of the exponential term larger. When converting to two scientific notation, a positive fixed notation number that is larger than 1 has a positive exponent. So this is 0 or higher in scientific notation. If our fixed notation number is between 0 and 1, like 0.25, then it has a negative exponent in scientific notation. And the number of places that the decimal in a number moves is the number after the sign in its exponent. When we're converting to scientific notation, we want to write the negative sign in front and then follow the same steps as for a positive number. To summarize, in your notebook, write a list of rules that we've covered. Write and recite this list until you can write all of the rules from memory. You need to memorize this list so you don't have to constantly refer back to your book. And then, and only then, do the practice problems from the book. So that was moving the decimal.